What if an AI could watch a tutorial and reproduce the workflow? Now it can. The following video was created with this method. March 2026. Rakuten unveils what it calls Japan's largest AI model ever built. Government-funded, homegrown, a national triumph. Hours later, someone peeks into the code. Buried in the file, the words DeepSeek v3, Japan's AI moonshot, was Chinese. Japan builds the chips, the robots, the precision hardware that runs the world's AI, but the intelligence itself keeps coming from somewhere else. The bill for that gap? $37 billion in 2023 alone. Rakuten created the model with subsidies from the government. It launched the model with fanfare, benchmarks beating GPT-4o, headlines calling it a national breakthrough. Then developers checked the config file. It read DeepSeek_v3. Rakuten had even deleted DeepSeek's license before rebranding the model as its own. Then there's Sakana AI, Japan's most celebrated AI startup. Its flagship product, Fugu, isn't a model at all. It's a router, a 7 billion parameter traffic cop that decides which American or Chinese model should answer your question. GPT, Claude, Gemini. Fugu owns none of them. And the money backing Japan's AI ambitions? Follow it and it leads to America. SoftBank, once Japan's most valuable company, has poured over $64 billion into OpenAI. Its big domestic AI launch this year isn't a Japanese model. It's a joint venture that resells OpenAI's platform to Japanese companies. SoftBank itself is its customer. And this isn't new. Japan's been here before. In the 1960s, it tried to outbuild IBM's operating system. In the 80s, engineers reverse-engineered IBM's code instead of writing their own, until IBM sued them for it. Different decade, same instinct: copy, customize, subsidize, rarely build. Japan has the money, it has the talent, it has the ambition to call itself a sovereign AI power. What it doesn't have yet? The appetite to actually build one. What you just watched was made with this skill. You give it a YouTube link and it treats transcript and frames as evidence and produces a comprehensive guide instead of you having to do any manual work. From that guide, it can recreate a specific scene or create new work with the recovered method. The skill is available on GitHub. Don't take my word for it. Please give it a try. To explain why I built it, I need to go back to the Obsidian workflow I had to understand and follow AI tutorials. I had a streamlined system in Obsidian for taking notes from YouTube tutorials. I could keep the video beside my notes, search the transcript for a specific phrase, and jump directly to the timestamp where it was discussed. If I needed to screenshot an important part, I could capture the frame I needed. But it was still a system for helping me inspect the video manually. It made the tutorial easier to browse, but it did not reconstruct the workflow for me. I could also use an AI and ask it to summarize the entire tutorial. That was useful for getting a quick overview map. The problem was that the map alone was not the workflow itself. The AI could summarize what the video said, but many important details were only visible on screen. A prompt might appear briefly in a side panel. A model setting might never be spoken aloud. The hierarchy between a reference sheet, an image prompt, and a video prompt might only be demonstrated visually. Those were often the details I needed most if I wanted to reproduce the result. So I still had to do the difficult interpretation myself. My system helped me find the evidence, but I still had to assemble the workflow. But Codex with Vision changed that. I could simply ask Codex to help me inspect the frames, read small details, and connect everything into a structured guide. That shift led directly to the reverse engineering skill. Let me give you a quick rundown of the workflow using this skill. With the skill installed, my first request is simple. I give Codex a YouTube tutorial and ask it to create a standalone guide. I'm looking for the method behind the result. What stays consistent, what changes between shots, which references are reused, and how each stage connects to the next. Behind the scenes, Codex reads the transcript, checks the visual sequence, and follows the parts where the workflow is demonstrated in detail. That matters because some of the most useful information may never be spoken aloud. A prompt, reference image, model setting, or handoff may appear only on screen. The skill connects those pieces before writing the guide. The result is 2 files I can keep using. The guide explains the workflow in plain English. The scene catalog gives each demonstrated scene a stable address. I do not need to search through the tutorial again or learn how the internal cache works. The evidence stays attached in the background while the useful documents sit in the main folder. For this tutorial, the guide recovered a simple production system. Build one visual style, keep it locked, then change the shot instructions for each short clip. It also recovered the reference hierarchy, the 2 production routes, the model limitations, and the point where exact typography or charts should move into a more controlled tool. The guide is a map I can navigate. The scene inventory breaks the demonstrated sequence into individual shots. Each scene stays connected to the prompt and source moment behind it. I can move from the full case study to the 3-card loop to the prompt that produced it. The inspection sheet makes that coverage easy to understand. I can see how the visual sequence was broken down. The supporting frames and verification records remain behind the guide. They are there so Codex can trace a claim back to the tutorial when I ask it to use the guide later. Now the guide becomes testable. For this example, I chose the 3-card loop and asked Codex to recreate it. Because the guide already exists, Codex starts from that stable address. It follows the selected scene, its prompt, its references, and the production route recovered earlier. For this scene, the skill identifies 3 required inputs: the main Vox-Style sheet, the correct starting image for the 3-card loop, and the full video prompt. This is where the guide becomes useful in practice. Codex knows which visual is shared across the project, which image belongs to the scene, and which prompt describes the motion. Codex uses the tutorial references to rebuild the shared style sheet and the scene start image with ImageGen. It keeps those generated inputs separate from the original evidence, then saves the recovered video prompt beside them. The prompts, generation records, and comparisons stay with the scene. If I revise it later, I can see what was used and what changed without searching through old conversations. Once the skill has identified and prepared the style sheet, the starting image, and the full prompt, I can send those inputs to Gemini Omni to recreate the scene. For this external video step, the skill stops and waits for approval instead of submitting it automatically. At this point, one URL has become a reusable guide, and a single scene has become a testable handoff. With that workflow verified against a known scene, I can now branch from the guide and use it with my own script. Recreating a known scene gives me something concrete to compare against. If Codex can find the correct style reference, rebuild the correct starting image, and recover the full motion prompt, then I know the guide can carry the workflow all the way to the final video generation handoff. That verification is what gives me confidence to use the same system for my own idea. For a new video, I share the same guide with Codex, then ask Codex for a short script about the shortcomings of Japan's current AI market. Codex can break that script into short visual beats that fit the Vox-Style format recovered from the tutorial. The subject changes, but the production logic stays the same. The main Vox reference sheet is already available, so it can be reused across the whole video. For each new script beat, Codex creates an image prompt, generates a scene start image in that style, then writes a matching video prompt for Gemini. Scene by scene, the package stays simple: one shared style reference, one new starting image, and one new motion prompt. The hard part was recovering the visual language and understanding how the assets, prompts, and video model work together. Once that system exists, I can change the script and let Codex adapt each new idea to the same workflow. For the next test, I tested the skill again on a different tutorial with a different production method. For my second clean test, I deliberately chose a harder kind of tutorial. I also used Cursor Grok for this challenge to test the versatility of the skill. The final output was not only a collection of prompts or generated media, it was a complete Vox-Style explainer workflow built with Remotion. That meant the skill had to recover more than the visual idea. It also had to understand how the scenes were structured, how the assets were prepared, and how the motion was implemented in code. I began with the same simple input, one YouTube URL and a request for a standalone guide. Cursor cached the source and transcript, inspected the full visual sequence, and reconstructed the tutorial storyboard, asset prompts, scene organization, and animation methods. It then stopped at the guide so I could review the evidence before asking it to recreate anything. After that review, I asked Cursor to rebuild Scene 1. It delivered an editable Remotion composition with the White House and both portraits in place, and the recreation landed almost perfectly. The final composite looked right, and every layer stayed editable. The motion itself got most of the way there. The Remotion render overshot a little on scale, so the finished video needed a bit of tweaking in the properties panel before it matched the target. For Scene 4, I asked Cursor to recreate another beat from the same guide. The assets came through in good shape, and the animation itself was mostly fine. The same editable Remotion setup we already saw on Scene 1. What still needed work was timing and scale. Same class of problem as Scene 1. The relationships were close but not locked. A few properties tweaks were enough to pull the motion and sizing back towards the source. I still would not call this a clean pass. It proves the skill can recover the workflow, generate the assets, and deliver editable code that gets most of the way there. What remains is the last mile of fidelity, catching timing and scale mismatches before handoff. That is exactly why I find this test more useful than a simple pre-generation workflow. Recovering a prompt package is valuable, but this case asks a harder question. Can the skill recover the authoring system itself, rebuild it in the correct framework, and preserve the visual relationships that made the original scene work? The answer is now much closer to yes, but the remaining fidelity gaps are still visible and measurable. One important note: skill can only reconstruct what tutorial explains or shows. If creator mentions tools or workflow but hides prompts, settings, and process, skill cannot faithfully recreate missing parts. It marks them unknown instead of inventing details. If you want to try the skill, the link is in the description. Please let me know if you have any problems. Reviews and pull requests are welcome. Thanks and bye for now.